sediment, which is the geologic materials that result from weathering, is going to be described in 3 different ways. The first is through grain size. So it's a pretty obvious one that just describes how large the individual particles are. And so we're going to look at 4 different sizes: gravel, sand, silt, and clay. And these go from largest to smallest. They actually do have actual sizes. I'm going to write those now and then talk about why that's probably not super critical to you. Okay, so gravel is greater than 2 millimeters, sand is 2 to 1/16 of a millimeter, silt is 1/16 to 1/256 of a millimeter, and clay is less than 1/256 of a millimeter. Now, you're not going to be able to tell that when you look at something. Maybe the sand and gravel you can, but certainly not the silt and clay. So I'm going to explain to you how you would determine this. So gravel, greater than 2 millimeters, we can see that. And that actually is going to be anything greater than 2 millimeters. So something like this big, that really is quite small, all the way up to something that's the size of a car, like a big boulder that's the size of a car, is a gravel. So gravel can describe things like boulders, pebbles, cobbles. Those are all different sizes, and your class might want you to know those. For my classes, we just care about it's greater than 2 millimeters, we call it a gravel. So sand is going to be something that's gritty. So you're gonna be able to feel that. And so it's less than 2 millimeters, but it's still gritty to the touch. And so 2 millimeter sand is gonna be pretty big, like coarse grain sandpaper. And 1/16 of a millimeter sand is going to be like really fine grit sandpaper, but it's all sand. And then we have silt and clay. They're both not going to be gritty. You're not going to be able to tell the difference between that. Although you can take a sample of that and rub it across your teeth. And if you do that, which is not recommended by dentists, the silt is more coarse, so it will feel gritty across your teeth. The clay is nice and smooth, really fine, and so it will feel really smooth across your teeth. But for practical purposes, we often lump these together and we just call it mud. Because really when it gets that small, for most purposes, it doesn't really matter. So the next way that we classify or describe sediment is going to be based off of rounding. And so this just describes how smooth or rounded the individual grains are. And there's lots of different variations of how we describe this, but I'm just going to use the 2 end members. And so we would call this well-rounded or angular. And then we have like moderately well-rounded and rounded and all sorts of things in between. But for our purposes, we'll just describe the end members. So our well-rounded, if we just took like a sphere, that would be well-rounded, nice and smooth. But also, this is an extreme example, this would also be well-rounded because it doesn't have any sharp edges. So you probably won't find a grain that's shaped this way naturally, but it just illustrates, we're just looking for smooth edges. Angular, it's just going to have a lot of sharp edges. So a box is a great, or a cube would be a great example of that. But again, anything that just has jaggedy edges is going to be considered angular. And the last thing that we look at for sediment to classify it is going to be sorting. And our 2 end members with that is going to be well sorted and poorly sorted. And for this, I just like to think about laundry. So if you have your big pile of laundry and everything is mixed together, the colors, the lights, the darks, and delicates, things like that, that would be considered poorly sorted. If you separate everything out into different loads where you just have the lights together and just have the darks together, that would be considered well-sorted laundry. So it works the same thing, but with sediment, it's size. And so a well-sorted sediment would be where you have a pile of sediment that's all the same size. And it doesn't matter if it's all gravel, all sand, all really fine mud, as long as it's all one size. So this would be well-sorted pile. This would be a well-sorted pile size-wise. That's what counts. So poorly sorted, you're gonna have lots of different sizes like that. So a good mixture. Now, it's important to recognize that even within sand, you could have a poorly sorted sand. So well-sorted sand, they would all be, let's say, 1 millimeter in their sizing. A poorly sorted sand might have sizes that go all over that range, and so that will eventually become important trying to figure out, did this sand form at the beach? Did this sand form in dunes? Did this sand form in a river? Those sorts of things.